In this video, we are going to discuss about design step for a riveted joint. First one, if the question is given, from there you have to find out the type of joint, whether it is a lap joint or butt joint, or in lap joint single riveted, double riveted, or chain or zigzag. But in the case of butt joint, single riveted, single cover, or single riveted, double cover butt joint, or double riveted, double cover butt joint, or zigzag type, or triple riveted. You have to find out from the given question. Then first one is type of joint and sketch. Draw the type of sketch and drawing. From the question, suppose design a double riveted lap joint. If they say that, then you will go to design data handbook K Linkaya, page number 13.16, table number 13.4. There it is clearly give the details of type of joint, their name and their specification, and for finding the pitch, transverse pitch, longitudinal pitch, as well as margin. The empirical formula is given in the table. In the case of, I will give an example. In the case of, in the question, if they say that design a double riveted lap joint, page number 13.6, table number 13.4. From there you will get to know the double riveted lap joint comes in the category of type B joint. Then type B joint, from the already sketch is given, you have to copy the same sketch from the table. Second one, you have to find out thickness of the main plate or base plate, the plate to be joined. See, it is mainly do for the design procedure longitudinal joint or boiler shell. In that boiler shell type problem, the thickness of the plate won't be given. Apart from the boiler type problem, they will give the thickness. If it is given a thickness, we can directly find out diameter by using another formula. But here we can see that if the thickness is not given, if it is given the diameter of the boiler shell and pressure inside the shell, efficiency of joint, if it is given, how can we find out the thickness of the plate? The equation is page number 13. In the case of a longitudinal joint, here you can see that this is a pressure vessel or boiler joint. Here the plate is joined by using, these are longitudinal joint. The joint is parallel to the axis of the vessel or boiler or cylindrical or circular plate or shape plate. Here you can a circumferential joint. The joint is arranged around the circumference. This is circumferential joint. This is known as longitudinal joint. Here this is a boiler joint or pressure vessel. Here you have to find out the thickness. If they given this diameter of the vessel, the pressure inside, the efficiency, you can easily find out the thickness of the main plate in the case of longitudinal joint. The equation you can get it from thickness is equal to T is equal to P pressure, the pressure inside the cylinder, into D diameter of boiler shallow pressure vessel divided by 2 into efficiency of joint and into sigma theta tensile stress. This one you will get the equation number 13.1 link here design data handbook. Design data handbook equation 13.1 you will get it. The thickness of a longitudinal joint, thickness T is equal to PA, pressure inside the pressure vessel or boiler, a diameter of boiler, 2 into efficiency of joint and tensile stress. These are equations for a thickness. In the case of a circumferential joint, if the joint is circumferential like this, the equation T is equal to Pi di into 4 eta sigma theta. This is equation point design data handbook. Design data handbook equation number 13.2. This is for circumferential joint. Circumferential joint. This T we can consider only in the case of pressure vessel and boiler joint. In the question, if it is T is given, no need to go for these equations. Directly we can for finding diameter of rivet. Step 3, diameter of rivet or diameter rivet and rivet hole diameter. Step 3 is equal to diameter of rivet and the diameter of rivet hole diameter. For finding this equation, D is diameter of rivet, D is equal to six root T to 6.3 root T. If it is given the thickness from this equation, we can find out diameter 6 root T, T is the thickness, to 6.3 root, either 6 root 3 or 6 root 3 you can take it. This one you can find out from the design data handbook. Design data handbook. Equation number 13.5C. 13.5C. From there we will get the value of diameter. Then already design data handbook, they have given a set of standard diameter of rivet. From the table you have to find out the standard diameter rivet as well as rivet hole diameter. For finding standard size of rivet and rivet hole, you should refer table 13.9. Table 13.9. They are given one column diameter of rivet, next column rivet hole diameter. Suppose imagine we are getting one value is 18.1, but in that table diameter 12, 14, 16, 18, 20. If 18.1, then you should go for next digit 20. The corresponding diameter also given. If you taken standard diameter is 20, then rivet hole diameter will 21. From there you have to select. Fourth one, pitch. Small p, pitch you have to find out. For finding pitch, one equation already there in design data handbook. For finding pitch equation, design data handbook, equation number 13.30. You can find the equation. The pitch is equal to 2I2 plus I1 into pi d square in tau divided by 4t sigma theta plus d. By using this equation you can find out the P. I2 means number of rivet in double shear, I1 number of rivet single shear, pi into d mean here you have to consider diameter of rivet hole instead of rivet diameter. This d you have to consider diameter of rivet hole. Tau means shear stress divided by 4 into t thickness of base plate or main plate, sigma theta tensile stress plus d diameter of rivet hole. Suppose from the table number 13.9 you will get it. Suppose you imagine the diameter rivet is 20, the standard size of rivet hole is 21. Then here you have to substitute in the place of d rivet hole diameter. Instead of 20, 21 you have to substitute here, these two places. This is one method. Next one, you can get it from the table 13.14. As I was talking about type of joint, page number 13.6, table number 13.14. From there already given the empirical formula of different joint. Then from there we will get it transverse pitch, margin and longitudinal pitch from the table. From table P you will get one equation for finding the P. This one you can consider P1 and this one you can consider P2. By these from this equation, from the table number 13.4, one equation is given. By using that equation you can find out the pitch value. Among these two values P1 and P2, you have to consider the permissible pitch is the minimum among two values. Suppose P1 and P2 you got it, and least of the least of P1 and P2 to be considered as a permissible pitch. Imagine by using this equation you may get 63. This one you get 62. Then 62 you should consider as a permissible pitch. Now imagine, suppose you may get a value 16.3. Then what that pitch is 16.3. That time you have to round to next digit, that is 64. Step 5, transverse pitch. See, transverse pitch in the case of joint. Transverse pitch means the distance between gauge line. This is known as transverse pitch, this distance. The distance between adjacent gauge line is known as transverse pitch. From the transverse pitch you have to find out from the table number 13.4 already given transverse pitch equation. From there you can, by using that equation you can find out the value of transverse pitch. Margin also is there. Next one, margin also you get margin M. This is PT transverse pitch. Margin M from the table 13.4 you will get it. Then in the case of lap joint there is no cover plate. We keep two plates. The main plate keep one over another that overlap each other. But if you consider, if you design for a butt joint,